Hi everyone. Assalamualaikum warahmatullahi wabarakatuh and a very good day. Today we will continue our lecture with solving system of linear equation. Alright, and before this we have looked into the operations of matrices. But before that we have learned on what is the system, what is the linear equations and how the linear equations can be transformed into matrices. Alright, this equation 2.3 is the linear equations, and equations 2.10 is the linear equations in matrix form. This one, alright. So this is the reason why we have looked into operations in matrices. So we have learned on the summations, multiplications, and we have recalled back what is the identity matrix and what is the inverse matrix and how to calculate or how to measure the inverse matrix. Okay. Okay, so okay, so alright. So this is an example of system equation. So remember, for the system of equations or linear equations, the main thing is for us to find the x value. If you look back into these equations, we have known the value for the matrices here and the product here, but not the x value. So this is the problem. Okay, and we need to solve it. And in order to solve, to get the x values, there are multiple ways. Okay, so in this case, we know that we have two types of equations. Okay, and the equations are x1. Okay, we have 1 multiply with x1 plus 0 x2 plus 8 x3 plus minus 4, because we have 4 x4. So we multiply with positive, we get negative, right? 42. And the second equation, this is the first equation. And the second equation is we have 0x1 plus 1x2 plus 2x3 plus 12x4 is equivalent to 8. This is our second equation. This is our second equation. Okay, so now in here we have two equations and we have 4 unknown values for the x. Okay, so however, these problems, we call the system of equation in this case, this problem is, we can consider it as a simple form. Okay, this problem appears in a simple form. Why? Because if you notice here, we have what we call as an identity form for this part, for the first part here, for the first two columns here. Okay, we have 1 0 and 0 1. This, whenever you find a linear equation problem in this form, then we can consider that problem exists in a simple form. Okay, all right. So okay, so okay. Okay. So okay, remember that we want to find scalars. We want to find the x1, x2, x3, x4 values such that the summation of the matrices and the x is equal to b, where we define the Ci to be the I column of the matrix and B will be the right hand side of equation 2.38. Okay, a solution in this equation 2.38 can be found immediately by taking the 42 times the first column and 8 times the second column. Okay, so if you notice here, okay, if you notice here, uh, if you notice here, okay, this part, it has 1001, and in order for us to get the first solution, okay, the first possible solutions, then we can reform the product, okay, the product here, the 42 and 8 in the form of 10 and 01. So we can adjust this form to be we can turn this form to be in this form. Okay, so how to do that? Okay, okay, so in this case, if you look here, 42b 42A is the B. Okay, remember this sorry, this equation here. Okay, so this is our B, and this is our B for the first value here, and this is our 8 in our second value in B. So we have the 10, which the 10 is the first column, and the 01 is the second column of our matrix. Just now. This one. Alright. So that is the reason why we can transform the B into here. Okay. So in this case, we know that the 42 and the 8 can be one of the solution. And this solution, we call it as a special solution. In the case of solving the linear equation, there must be two types of solutions. First, we call it as a special solution plus with the particular solutions. So basically, the solutions for the linear equation will be in this form. X P for the X C, meaning the C meaning complete solution, equivalent to XP. P is the particular solution plus X S special solution. Alright, so the complete solution or general solution will present that we present a complete solution lah. Okay, so whenever the question asks you, please solve the equation blah 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 blah. So you need to make sure that you get the particular solution as well as the special solution. Okay, alright. So, however, this is not the only solution for this linear system of equations. So, okay, alright. Before that, as I mentioned just now, this is your solution 42800. So the 42 is the solution for the x1, 8 is the solution for the x2, 0 is for the x3, 0 for the x4. Alright. So okay, that will be the first possible solutions. And then, therefore, to capture all the other solutions, we need to be creative in generating zero in a non-trivial way by using the column of the matrix, which, in other words, adding zero to our special solution does not change the special solutions. Okay, fine. That is just a sentence. Okay, so Alright, so to do so, okay, to solve, to get the other solutions, we express the third column using the two columns. Okay, so in this case, we have several ways. This is one way. Based on these textbooks, this is one way to get the other solutions. Okay, so I will explain to you the first technique, or the first method lah. Okay, so basically what is presented here is, it is similar as previous. Okay, it's just now we present the B value in the first and second column of the A. Alright, so in this case, we present the third and fourth value of the matrix A into the first and second column form. Okay, so this is the equation here, right? The equation 2 point. Okay, let me copy this again. Paste it here. Okay, so this is the equation here. We have settled with our first possible solutions. So now if you look into the A part, this is the A matrix. Okay, remember the form, the AX equal to B. So the A matrix here, for the first two columns, it appeared in a identity lah, sort of identity matrix. Sort of, not really the identity matrix, but the form too it's looks like an identity matrix. So, but if you look into here, if we divide the matrix, okay, the first two columns ni dah in a simple form. So now we have to solve, or we have to reform the third and fourth column to be, so that it can be presented in the first and second column. Okay, how are we going to do that? So now if you look into here, we have 8, 2, and this 8, 2 is the third column from the matrix A. We have the 8, 2. So how to present the 8, 2 in the form of first and second column? Okay, so we can extract the 8, and then this 8 we can multiply with 1 0, and the 1 0 is basically from the first column, plus with 2, this one 2 here, we bring it here, and this 2 we multiply it with the second column from here. Okay, so we get this we get this solution. Okay, so from here we can derive the solution. So what is the solution? The solution is 8, 2 coming from here, minus 1 and 0. Okay, so you have to make sure that when you have the solutions, these solutions will give you equivalent to 0. Okay, yes, to 0. This is one way of getting this value. Another way to get that, to get the value, and please take note that this value is not fixed. It must be 8 to minus 1 0. Minus 1 0. We will get this value if we use this approach. Okay, if we use this approach. Alright, so if we use another approach, okay, another approach. So how are we going to do that? Allow me to have this. Let me to copy this and to paste it here. Okay, so now in here, if we rewrite the equation, this equation, into into the original form, then we will get x1 plus x1 plus 8x3 minus 4x4, and similar as in this similar as in this condition, we have to make sure that what we generate here is equivalent to 0. How to edit this one? So we have x1 plus 8x3 minus 4 x4 is equivalent to 0, and then x2 plus 2x3 plus 12x4 is equivalent to 0. Okay, so in this case, there is no problem with the x1 and x2. Before that, I forgot to explain to you. So, in this case, there is no issue with the first and second column, right? Because it has already in the form, in the simple form. But if you look into the third and the fourth column here, then we can call this column and this column as a free variable. Okay, there is no issue with our x1 and x2. Okay, and but for the x3 and x4, because it's still in a complicated form, so this x3 and x4 can be what we call as a free variable. It can be any numbers for the x3 and x4. Okay, so if we modify a bit this equation, the x1 plus x3 minus 4x4 to be x1 equal to 8 minus 8x3 plus 4x4, and x2 is equal to minus 2x3 minus 12x4. Okay, and we transform this form into matrices. This one, the right hand side into a matrices. Then we can get alah. Boleh. So we can make it minus 8x3 plus 4x4, and in here is minus 2x3 minus 12x4. Here is x3 and here is x4. Okay, alright. So we let's say we let x3 equal to 1, x4 equal to 0. Remember, whenever we declare that variable to be a free variable, we can put any numbers, but usually we will use the simplest numbers, the simplest integers. Like in this case, I start the x3 with 1 and the x4 is 0. So if we plug in this value into the first and second row, then we will get x1, this is the x1, this is x2 kan. So the x1 will be equivalent to minus 8, and our x2 is equivalent to minus 2. Alright, and then our x3 is equivalent to 1, our x4 is equivalent to 0. So this is also can be the solutions for the third for the another possible solution. And if you notice, there is a slight difference between these solutions with 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 this one, right? Just now I got the previous solution is this. Okay. So if you notice, okay, so if you notice, the first possible solution is this 8, 2 minus 1, 0. And when I do the second approach, I get a slight different. It's still same, but there is a small change. There is small difference. Okay, this one I get minus 8, minus 2, 1, 0. Because of these differences, that is the reason why we need to include scala for this solution here. Okay, so since that the x4, okay, the x4 is 0, so when we plug in into this equation, the x4 is definitely 0. But this solution here, remember, this is the A matrix, this is the X matrix. So this is the second possible solution, and this second possible solution, it can give us a different sign for the same number. So that's why we need the scalar here, the scalar 1 here. Okay, and then you can do the same approach to get the possible solution for the fourth column. Okay, you can either use the technique presented in these textbooks or what I have explained just now, the second approach. Okay, so for the second approach, if you want to know more, you can refer to the YouTube links here. Alright, so now we have basically three solutions. Okay, we have the special solutions just now. Okay, we have the special solutions just now. Okay, sorry, this one. Okay, this solution, and we have these solutions with scala. We have the next second solutions with the scala 2, and hence when we put it together, all these three solutions, we will get what we call as a general solutions or a complete solutions. So this complete or general solution is basically a combination of particular or special solution. Okay? Alright, so that will be for the first. So, okay, the general approach we follow consists of the following. Find a particular solution to Ax equal to B. Find our solution to Ax equal to 0, and then we combine the solution from step 1 and step 2 to generate the general solution. The system of linear equation in the preceding example was easy to solve because the matrix has the particularly convenient form, the 1, 0, in the first and the second column just now, which allow us to find the particular and the general solution by inspection. However, general equation systems are not of this simple form. That is why we will need what we call as a Gaussian elimination, which I will show it to you in the next video. Okay, thank you.